everyone, it's Judy Warner. Welcome to the special edition of Onsite Insights from the EEcosystem Podcast. In this episode, I recap a presentation and executive roundtable I recently attended at EMD Electronics in San Diego. EMD is an advanced packaging materials company, and they brought together some of the brightest minds in the semiconductor industry. Joining me today are Krishna Arangode, who is the CEO of Kaisen Analytix, and Venky Sundaram of 3D System Scaling. We discussed the opportunities for AI, LLMs, and how that, coupled with the power of data analytics, can enable greater ecosystem cohesion, and how critical data-driven intelligence continues to drive technology forward and accelerate hardware design flows for engineers like you. A special thanks to EMD Electronics for hosting me and allowing me to record this podcast in their beautiful facility. Without further ado, let's jump into our conversation with Krishna and Venky. Hi, everyone. It's Judy Warner. Thanks for joining us today. We are at EMD Electronics in San Diego, and I just had the pleasure of sitting through a fascinating presentation with Kaisen Analytix and also my friend Venky, who is involved in the semiconductor industry. So, gentlemen, welcome, and I'm really looking forward to this conversation. So, Krishna, why don't you start out first by introducing yourself, telling us a little bit about your background, and then also tell us a bit about Kaisen.
Thank you. Thanks, everyone, for joining this session. So, Krishna Arangode here, founder and CEO of Kaisen Analytix. We are based in Atlanta. We have offices in Plano and New York. And we've been around for about 9+ years now, 80 people strong. Primarily a services company, helping companies figure out how to use data and analytics to drive value. That's what we do very well. We work with a lot of different industries and companies to unlock value from their data.
Well, Venky, today we're here talking specifically about how Kaisen can bring value to the semiconductor industry, which is something you know a lot about. So why don't you introduce yourself and then we'll jump in.
Thank you, Judy. Hello, everyone. This is Venky Sundaram. I have been in the semiconductor industry for 25+ years now, and most of my time has been in what's called advanced packaging, at both at chip level and system level. And through my career, I have built a couple of successful startups in the semiconductor industry. I've also built large programs for global industry consortiums. One of the favorite projects I pioneered is actually glass packaging, which is currently going through early phases of high volume introduction. So I'm very proud of that. And I've always been fascinated by data and the intersection of data with the semiconductor industry. In fact, semiconductor industry enabled AI by developing the chips required for it. But we are probably in the early stages of using AI for our own needs. And Krishna and I have been connecting at various points in time on how do we bring some of the value that they have brought to many other industries globally using data analytics capabilities to actually understand more of your own business and extract more value. And so I'm really kind of fascinated by this intersection of my experiences in the semiconductor industry, developing and introducing new technologies, new products, and Krishna and the team's capabilities in AI and data analytics. And how do we actually create some magic together?
Right. That's the goal, isn't it? So during your presentation, Krishna, you talked about different types of industries you're working with and some types of value you've been able to extract and pull out and bring very impressive results using a sophisticated stack of both customized tools or existing tools and pulling that all together. Can you tell us a little bit about some of those customers and some of the successes you've been able to bring to bear?
And thanks, Judy. So we often, again, focus on, and the reason we named the company Kaisen as well is because we take an incremental approach to driving a lot of this value and transformation in organizations. It takes many steps to get often where companies are trying to get to, and we've been kind of educated along the way by Kaizen principles, which is commonly adopted in the manufacturing space. But we want to bring that to the technology and analytics space, and think of the journey and think of the incremental improvements one can make, and keep that value in front of us always, so that we are showing that proof point along the way. So that's been our approach. And again, we work with automotive OEMs, we work with um, travel and hospitality companies, we work with uh, energy, chemicals, industrials, large metal manufacturers, and we have brought in transformation both at a technology level, at a design and engineering level. That unlocks a lot of value by bringing together data and a new way of looking at things across the enterprise.
Very good. So much of what we're talking about is an industry, from semi all the way down the entire hardware ecosystem is AI and LLMs, excuse me, AI and LLMs. So what are from your perspective and your company, what are both the challenges and opportunities that both AI and LLMs bring to the technology space?
So it's a great question, Judy, and I'm just reminded of a recent conversation with my son or sons, my twin sons. They, came up to me and said, "Hey, I generated a business plan from ChatGPT, and this looks cool. See how well it is written." And it was fascinating. I mean, you look at it, it has thought through all angles, and it has. Another interesting aspect is they generated a contract that was fairly well thought through by ChatGPT, and these things have been simplified today because of the presence of AI LLM tools. What I often say is there is a lot of enablement that has happened for that to be possible. And this is what we try to tell our clients, in building a data platform that they can rely on to bring these tools into place. Companies have to invest time building trustworthy data infrastructure that these LLMs can tap into, and then there has to be a lot of thought that goes into not exposing that and keeping proprietary information internal. I have had, sometimes I hear folks interacting with tools like ChatGPT, and there is proprietary information being lost. And I encourage clients to think about creating private LLMs, which where it remains within your four walls, and there is a level of security you can enable. Now, in general, AI LLM tools tend to work with a lot of patterns it observes on data and brings that to your attention. And I would also say that use it a lot for alerts, use it a lot for scenario planning. Those are great use cases for LLM, right? Like, engage with it so that you can assess what happens under different scenarios, and it can connect a lot of data points and bring that to your attention, so you are not spending the time thinking about it. But there has to still be a human involved in this journey. There is then a lot of this value cannot be unlocked if the human brain is also not engaged in the process. So that's at least what I have observed.
And that is one of the challenges, right? If we take it at face value, I bet your kids think they're going to go out and start a company better than Deb, right?
Yep.
So, yeah, if only it was that easy, right? And I know from my background, both in technology and in marketing, when it spits out answers, general answers, I know from working in large global marketing companies, is that sometimes they are so much demand on putting content out, and they've actually not cared about how accurate that is.
Yeah.
As long as we get clicks.
Yeah.
And from inside the company, I'm like, stop doing that. Stop. Engineers have enough trouble on their own. Don't put this out. And they're like, no, I just get rewarded for clicks. I'm like, this is bad. So if we're pulling generalist LLMs and asking to do anything with any kind of complexity, we're definitely courting trouble. And a lot of companies I'm talking about, AIs and LM, are still talking about the importance of the engineer in the loop.
Yep.
So, Venky, you and I have worked with design engineers, and we've both been exposed to, one, a complex stack, but also, particularly since COVID hit, the design cycles have been compressed. At the same time, we're asking them to do more, fewer spins, and shorter lead times. So as you and Krishna talk about these technologies and how maybe you customize LLMs and scrub the data and protect the IP, what are maybe some of the opportunities that you're observing, or how do you frame this as a professional in the semi industry of how can this maybe help that compressed design cycle, particularly around the semi industry?
Yeah, this is a fascinating question, and also there's an inflection that we have been following for a number of years, Judy, which is systems, electronic systems used to be designed on single chips and on circuit boards, right?
Right.
So the whole industry's ecosystem and infrastructure was built on, there's a company that makes the chip, that designs a significant portion of the system on this chip, and so they can internally control and accelerate that development as needed.
Right.
And then the system makers would basically say, I'm going to design a circuit board and I'm going to buy component A, B, C, and D,
Right.
and I build my system. So it was a very efficient and rapid cycle, right?
Right.
But fast forward to today, and more so tomorrow, what has happened is the systems have become a lot more complex, right? And what we call heterogeneous integration is everywhere, right? So you are now building systems that include, computing, communication functions, photonic, channels. So the system complexity has increased tremendously, right? And the other thing that has happened is really, things such as chiplets that have showed up, right? So what that means now is that the design process is much more fragmented. So now as a designer, as a system designer, you're sitting and saying, now I need to procure, this many chiplets from, this vendor. And now there are 20 different chiplet vendors that I need to buy from. And now I need to design, a system that has a common interface with all of these components that I'm buying. And these are not pre-tested discrete components like the old days where you plug and play. Now you have to actually custom design a lot more.
Indeed.
Right. So as an example, if you look at large chip makers, I was talking to one of the large chip makers, and they were talking about accelerating design cycles from 18 to 24-month cycle time to 3 to 4 week cycle time. So and this is basically actually created by the introduction of AI in one sense, because the product turnover has to be much faster. People are looking for higher bandwidth, more functions, much faster than they used to, right? And so from a designer's perspective, depending on the traditional methods of designing systems is not going to keep up with this pace, right? So I think we have to at some point leverage the tools that Krishna talked about, the AI tools, right? And it's not like you use ChatGPT to design your product. That's not the point, as you said. But what are those LLMs and what are the generative AI capabilities that now you can build into your own stack, right? And change the way you design, right? You're not in a manual design mode. You're in a much more automated design environment.
Right. But you give it the constraints, correct? You make sure the data is good, which is is something. And then on top of that, I heard during your talk, both of you gentlemen talked a lot about standards and regulations. And so, Krishna, what role does that play? And like, where do you put the constraints? It seems like an overwhelming complexity of issues. I'll let you both talk about this. Like, where are the constraints? Where do you start? And then we'll wrap with maybe a little bit of vision casting. So
Yeah,
talk about standards and regulations as a starter, and where you put those early constraints into to mine the data and to begin maybe building like a backplane that
Yep.
understands all these dissimilar parts.
Yep, maybe I can go and then you can follow me if you want, Venky.
yeah, actually that's fine. But I can also, like, let's say maybe I provide some context from a semiconductor industry complexity. Then I'd like to maybe Krishna to
that's
talk
a good
about,
idea.
how did you deal with this type of regulatory or compliance environment in other industries like automotive? I think
Yep.
it's a great example.
Yep.
Right. So I would say just a very quick segue about it is that there is ever increasing regulatory and compliance driven complexity in our semiconductor industry. I've never seen this type of multi-factor convergence, I would call it, in my 25-30 years of being in this industry. So for example, just sitting in this room today, right, you look out, there are geopolitical driven issues in the semiconductor industry, supply chain resiliency issues, whether it is geopolitical driven or whether it's critical minerals issues, right? Or sometimes there's natural disaster issues, because semiconductor industry is one of the most single sourced industries out there, right? And there's a lot of innovation, and not every supply chain is capable of dealing with it, right? So I think in the lookout ahead, this is getting even more complex, right? The geopolitics is especially related to AI. There is a very strong nationalistic tendency with AI, right? And you see, for example, many nations are investing in parallel in the same capability, right? And they're also saying this is now going to create restrictions, additional restrictions, and additional regulations and compliance requirements, right? And this is something we are not as experienced with as some of the other industries. So I think that's where I would like to see Krishna comment a little bit more about what have you done in other places that is really valuable and could be ported over to accelerate our journey into this compliance environment.
As you lean into that bit about automotive, why I think that's highly relative to our discussion is that it's some of the most demanding regulatory work. And as we move to autonomous vehicles, it's going to get worse. So, but as I heard one say, like, how do we lean into this? What are your learnings? And how do we not get frozen and stand around and admire the problem? How do we find our ways through?
No, that's excellent segue. Thanks. It is true that the automotive OEMs are in highly, the regulations are increasing exponentially. The compliance requirements are increasing exponentially, and there is a lot of platform development going on to bring all the necessary data together. Sometimes there is many levels of the supply chain, right? We all know how highly connected the automotive supply chain is between tier 1 vendors, tier 2 vendors, tier 3 vendors, and the data needs to flow from all these sources so that we can do those assessment as to, are we meeting the compliance requirement, are we meeting the regulatory requirements. So, and companies have been building infrastructure to enable that exchange of data across providers of these services. So there is a lot of systems put in place that enables that problem solving, and I am sure the semiconductor companies and should look into beginning to create such integrated data platforms and for the information flow to happen so that one can start putting a toe in the water and enable these tracking mechanisms. Now, one other thing I'll say, it is very common. It's not just semiconductor. Even many companies face this. Like there are like myriad set of technologies internally, even right.
You bet.
And we have heard of softwares like PLM softwares and so data sitting in all these technology stacks. I sometimes say that Excel is the world's largest ERP system. Excel has so much valuable information sitting there at companies, and building some way of bringing all that together so that the value can be unlocked and the value can be tapped is another key advice I will probably have. And what I would encourage is to focus on that value, not on the complexity of, oh, I have to connect all these, what am I doing it for, how do I just focus on the value, focus on taking a small step in unlocking some either a regulatory compliance achievement or a market potential identification or a market opportunity identification or driving additional margin, whatever it is. Take that value and then back into what sources do I need to connect to, what do I need to assemble, and how do I need to unlock that. And then that often snowballs into bigger and bigger opportunities. So I would encourage everyone to like think and start small and then build on it.
Reminds me of that proverb about how you eat an elephant, right? One bite at a time. You do it incrementally. Oh, the last thing I want to ask you about before I let you get away, because we've had a long day and I know we're all going to go eat dinner, but IP. IP is always the problem. Definitely inside of the semiconductor industry like no other. They do not want to expose their IP. In my work at Altium, they were developing a cloud-based tool, and they were actually able to code a bridge between dissimilar software programs that was able to hide the critical IP. How do you handle this, Krishna? Are there ways that you either keep things on premise or like how do you tackle the IP issue? This seems like a big, gnarly one in our industry.
Yeah, I want to actually just make a quick comment, then I'll let Krishna talk about specific experiences. Right? Um, you know, in the semiconductor industry, you are absolutely right. We are very protective of intellectual property because it's a very innovation-driven, value-driven industry, and we pride ourselves as users and suppliers on being first to market, having a lead time where you can make the margins required to justify continuous investment. So absolutely spot on there, Judy. But the other point is, just step back and look at how we do things manually, right? Not the data part. So we even in the semiconductor industry have tons of non-disclosure agreements, bilateral, between suppliers and customers,
Indeed.
and between suppliers and suppliers, sometimes between competitors, and we under those legal frameworks exchange proprietary information every day, right? And I basically see the opportunity to automate that exchange, to bring that security embedded into the platforms that Krishna and Kaisen and other folks in the industry are building. I don't see a barrier to transferring that. I think people just think, okay, we cannot share data across companies, but we share data manually across companies. So why not share them automated in systems?
So can you shield that IP in
Yeah,
certain cases, or how do we do that? And by the way, I think I have to say I've seen that over and over again with like I remember particularly Samtech was talking about they were doing, high-speed flyover cables chip to chip. And they were talking to one of the big semi, and he's like, hey, we're going to go up to whatever, 224G. We need this data on RP. And he's like, oh, no, that's our IP. We're not going to do it. And he's like, I can't build my product unless you give me the IP. And we're already kind of doing it anyways. And so there is that. But anyway, shielding IP.
I mean, you can create private clouds, you can create private LLMs, and I think just giving thought to it beforehand and designing a platform that respects it is possible today. And we have done it for large companies, medium-sized companies, where we have enabled that protection of IP, protection of proprietary information. We in fact encourage execs to think about it beforehand so that they can design a tech stack and an approach that protects it. Because at the end of the day, that's their competitive advantage. You want to respect that, and you want to create a safe environment where they can do those assessments and scenario planning without fear of losing that information externally. I mean, that's another reason you don't want to be on the public LLMs. And in fact, you might want your company infrastructure to also control access to public LLMs and public tools, and start creating a way to protect that information. So I think careful thought and early on will help you design a stack that will enable that and not compromise that, is what my thought would be.
Well, gentlemen, thank you so much. This has been a fascinating presentation. It's been really a delight to learn about what Kaizen's doing, really globally, and so many different industries. And it's exciting, Venky, for you to be leaning into it along with EMD and many thought leaders that were here that were so impressive today, sitting all at one table trying to think through how to enable this for our very complex, riddled industry. But gentlemen, we're in a brave new world.
Yeah, it's going to be interesting.
It's going to be an interesting ride, and we're all on it. So thank you again for sharing your thoughts and your experience. And I look forward to checking back with you perhaps later on and see how far you get and the doors that you open for the industry.
Appreciate the opportunity.
Yes, thank you.
Yeah, and thank you, Judy. I think I really appreciate the opportunity, and also thanks to all the listeners. I think we are just beginning to unlock the exciting possibilities of using AI inside the semiconductor industry, not just enabling it, but actually being a user of it.
We are pretty silly that way, aren't we?
There is so much opportunity. I think we are just at the tip of the iceberg in using this, and our industry, semiconductor industry, needs this badly too, because we are at such a rapid innovation pace.
Right.
We would be a power user of this technology capability.
Well, we certainly need it, and the world's not slowing down. So good for you both for having early conversations and leaning into it. Like you said, it's so silly that Semi really creates the chips that enable AI, that they're like, no, it's my IP. I don't want to share it, right? And it reminds me, one time I met a gentleman quite famous for developing HCI technology, and he worked in Taiwan for 12 years for Foxconn and was responsible for developing something like 50 million of the early iPhones and figuring out how to put them into printed circuit board form, and really teaching Taiwan how to do that. And he was fascinating. And then we finished our conversation. He picks up a flip phone from Target. And I said, Happy, you made 50 million iPhones. What are you doing? He goes, I just need to call my wife. It's, I don't need it. So here we are, That's sort of a picture, I think, of our industry. We enable
the story. I'm going to use it.
Right? It's a good one. So again, thank you so much. I've enjoyed our conversation. For our listeners, I trust you've enjoyed this interesting sort of macro level idea of where the industry is going, how we might leverage AI and data analytics so we can get more and more insights and be more agile and speed up your design cycles. So thank you again for joining us today. We'll see you next week. Until then, remember to always stay connected to the ecosystem.